Welcome to the class. This is the January 2024 class. This is a subset of what I run as an AWS Security Fundamentals Bootcamp. And the topic for today is Introduction to AWS IAM. This is the agenda for today, what we'll cover at least in the next hour. And the idea behind this is we are able to at least go through what IAM is. So leveling the playing field for when people really talk about IAM, what do they really mean? Now, I appreciate some of you may already be experienced, so it may be a repeat of what you may have already heard of. And perhaps it could be just a refresh of what you've done before. But we have a mix of experience in the class today. So I just want to make sure that everyone is well equipped in at least their understanding before we do this. Also, towards the end, I'll have a lab as well. We'll walk through an AWS console and show you what I've learned and how you can learn it as well using some of the regular things that most people have been able to do on the internet. Housekeeping rules is that we obviously have this booked for an hour, so probably an hour-long video for people who watch this later on. But the intent is you should be able to ask questions. Feel free to keep dropping your questions in the chat, and I can answer them as I get through them. But my aim would be I want to be able to at least go through some of the labs because being AWS IAM, I think you'll probably get the most value from the lab. So I can quickly go through the theory, set the premise for some foundational pieces and go through the lab. IAM explained. Identity and access management are technically two different concepts. The reason they are used together, to simply put, identity access management is how do I make sure the right people have access to the application they are allowed access to? Now, by saying that, what I mean is if you folks use LinkedIn, Instagram, Facebook, whatever social media platform you may be using, you would have a username password that is private to yourself. You would only want yourself to be able to access that. And you would expect whatever social media platform you're using, they would make sure that they are following the right identity and access management practices. So I can't log in with your email credential or your social media credentials. Translating that onto a company or a private use or a company use case, identity management in that case is only allowing authenticated user. So authenticated users in this case would be people with the right username password. And for folks who are performing just identity management, the scale for understanding of this, it's literally any user that is created, modified, and deleted. Or in the identity management term, it's called provisioning and deprovisioning of users. That is what identity management is. It is usually the first layer of defense you have for applications. We are all either our existing security people or we are trying to become a cloud security person. Your first layer of defense for any of the cloud service provider, this is not just whether it's Azure or Google Cloud, is identity and access management. If you don't have the right credentials, you cannot access someone's account. In fact, if you were to go and do an analysis of all the hacks that have happened on the cloud data breaches, most of them occurred because someone lost access to their credential. Someone kept their credentials onto a GitHub repository, which is a popular source for storing code. That's how most of the data breaches happen. So if you are able to get identity access management right, that is already doing a lot better than most people out there in terms of doing security. In saying this, who makes the decision for identity management? Usually in companies, there is someone known as a product owner, or in some small companies, it could be the CEO. It could be the CTO, or it could just be a team leader, depending on how big the organization is. The decision for what resource or what application can be made public is also reliant on the business itself. So ultimately, the decision for what requires authentication versus not authentication is the business call. But depending on what layer of the organization you're working in, you may find that most of the decisions are primarily made by people who are building the application, which also brings me to access management. Now that you've built the application, you're trying to secure it, you've made sure that, only Ashish who has the authorized access, or only Peter or Ashwin or whoever is on the call here are the only authorized users who should be able to attend this call. How do you make sure that I'm even allowed to get access to that application? There's one thing that I have username password, so I should be able to authenticate. But the second layer is authorization, where say I work for, I don't know, just insert company, let's just say Tesla, for example, and I normally just do my developer work. I build cloud security infrastructure. Should I be allowed access to salary information for everyone? Maybe, maybe not. Probably my own salary, yes, but I wouldn't want to know how much is Elon Musk making. Not that it's not public, but I'm sure we all know how much he's making. But the point being, there would always be access management questions you would be asking for every application you're trying to protect. These are applications that are built on the cloud. Now, who makes the decision for access management? 90% of the time, in all the years that I've spent in cybersecurity, 90% of the time, access management decisions for who is authorized to access an application is usually made by the decision for that is usually made by the application owner themselves. It is not people like us or security people or about to be security people. We can guide them on whether they should go for this or not, but ultimately the access management information is for whether Ashish is authorized to access the application or not is left to the application owner, the people who created the application in the first place. Now, that is the foundational piece of what IAM is. Once we've understood the foundation, let's talk about why is it important in the first place? I mean, it's great. Isn't that just username, password? And I often ask this question to people who are in the space for a long time. If you have been using data centers, which are on-premise data centers, as people like to call them, or some people call them traditional environments, but I think they're still very much relevant in today's day and age. In a traditional environment where IT was done in a non-cloud environment, the first layer of defense used to be network. Unless you are inside an organization and you can plug your laptop into the network cable or the network of the organization, you cannot do anything. However, the tables kind of flipped in the cloud world. In the cloud world, anyone can access AWS, anyone can access Azure, anyone can access Google Cloud. The only defense you have is the credential. Like I can go on to console.aws.com right now, and if I knew credentials of Ashish, who happens to work at Tesla, I can log in with their credential, and that would be that would be it. Like I think that is why the IAM is probably the most important piece. And going back to what I said about most of the data breaches happen because of someone losing access to their credentials is probably pretty good enough reason for why it's still the first layer of defense, and getting that right in the beginning is very important. So what is AWS IAM? Now that you understand the concept of IAM in general, what the foundational piece of why IAM is important, it is also important to understand that actually, I would say before I talk about AWS IAM, just a general note statement that the way identity and access management would work in AWS would be different to how it would work in Azure. It would be different in terms of how it would work on GCP. They would not be different in terms of the foundational thing I just spoke about. There is still authentication, there is still authorization, there is still separation of roles based on, or separation of access based on what role you have. But the way it would be different is that there would be nuances. For example, AWS IAM is, and I should probably call it AWS IAM users to not confuse people. AWS IAM users are local users in AWS that you can create, which do not exist in your company or in the organization you would be working for. These users would not exist over there. And you can operate on them. And you would create these as part of the lab. We'll go through this, but you are able to create IAM users which are completely unrelated to the users you may have in your company. And that's why I guess the security risk also comes from it, for the fact that, hey, am I able to just log in with my AWS IAM users? And that's how you can completely bypass any controls you may have. Which brings me to the point of people like all of us who are going to be users of AWS. We are technically AWS customers, whether you log in and create a console account yourself, or you are working for an organization that is using AWS, you would be called an AWS customer according to them. So I'm going to generalize it by saying AWS customer employees. The other kind of user is machine user. There is a lot of automation that is possible. Now, machine user is a concept that is new and it was introduced with cloud. There have been terms like system users that have been used in data centers, but they didn't have the same meaning. In machine user context of a cloud, a machine user can be automatically triggered by, say, just the event that I reset my password. So that can trigger a machine user to do something. Another kind of user you would find is third-party user. Not all cloud service providers have everything you would need to run and operate in a company, to secure everything in a company. So the way you would operate in this would be, you would have third-party softwares to help you with measuring the performance of how is your AWS environment doing? How is the logging or the logs being collected of applications that are being put in there? What would be a good way for you to measure the security posture of the cloud account you have? All that is achieved through third-party users. In saying that, if you are working for a company and you use AWS in the company, you would find that your company that you work for, let's just say in this case, I'm going to use the same example of Tesla. Tesla has customers as well. That's being represented over here by AWS customers users, where we may be creating applications on AWS. And the users that would use those applications that are created by us would be the AWS customer users. Now, IAM is obviously more than credentials. All of these users would have credentials, but IAM is a bit more than that. IAM in AWS has a root user, which is when you create a console user for the first time, you go on AWS console and you register yourself for a free account. You put your credit card information in, you put your username, password, and everything. That account is the AWS root user. That is probably the most important user you would create in an AWS context, because that user is what is used to create the AWS IAM user that I was referring to before. Now, AWS IAM user, we'll go through this in the lab later in the class today, but AWS IAM user, as I mentioned, is the local user for the account that you create in your AWS account. The way you would secure them is the good old strong password and multi-factor authentication. It is a good practice to have multi-factor authentication for AWS root users as well, and not just your IAM users. I would say probably more important to have root user have a multi-factor authentication than, say, a local IAM user with no permission at all to have a multi-factor authentication. However, if you're a local IAM user with admin privileges, you probably want to have multi-factor authentication. So I started working in the cloud security space about 7 years ago. As much as it sounds like 7 years ago is a long time in the cloud world, but it's probably in real life, it's not that long. When I started at least working in this space, most people and most companies would only have one AWS account. These days, there are multiple AWS accounts. Multiple users are given access to AWS console across a company, and it is not easy to manage, say, even in this call right now, we have about 50 people over here. And imagine managing 50 people with 50 different roles, making sure everyone has strong password, making sure everyone has multi-factor authentication, but also going back to our creation, modification, and deletion. If someone over here gets promoted to become a cloud security engineer or a senior cloud security engineer, that would require change in permission for what they can do on AWS, but then multiply that by 50. So the scale of how complex identity access management can be is basically, well, I would say people definitely underestimate the amount of effort that could be involved in looking at just managing identity across multiple AWS accounts. Especially if you add the fact that in one single AWS account, you could be working across multiple geographies where, fortunately, because AWS only allows users to be created in the context of that AWS account, as long as you're aware of AWS accounts that you have, you can independently manage IAM users across the board. Now, there is a concept called cross-account role, which I'll come to later, but probably too advanced for this part of the class. However, the common practice these days is when you are looking at having a AWS IAM being defined for an AWS account, the way to approach that would be to have something called AWS Identity Center, which uses an existing user data store. Common examples of user data store is Entra ID or Active Directory. This is basically that one storage space where all users of the organization or all employees of the organization are created. So every time you join a new company, they are creating you in a database. And that database, I guess examples of those databases are Entra ID. Used to be called Azure AD, but now it's called Entra ID. So I'm going to use a new name. And Active Directory is another common example of it. This brings me to access management. So access management, I spoke so far about AWS IAM user. And the AWS IAM user is the local user you can create on AWS consoles. The way to restrict what these users can do is using something called roles and permissions. I would probably say roles and policies is the right way to explain it. Permissions are subset of roles, and you would see this in the lab later. IAM role is the role that defines what permissions a user would have. Instance role are not attached to just a user, but can also be attached to AWS services, aka the machine users that I was referring to. Like machine users can actually have permissions to do things that they want, which is not usually spoken about in identity access management for on-premise data centers. So that makes it even more unique for the cloud context. And lastly, policies. Sometimes roles are not enough to define what you need to have. So you may define additional permission or put additional controls and boundaries for what people can do using something called policies. And we'll go through that as well in the lab. That's how you would do access management for AWS IAM users. Talking about user management. So we spoke about authentication. We spoke about access management. The last piece is more about create, modify, delete. How do I make sure that I'm able to do this extensively? For people who probably work in an organization at the moment, if you look at something called security assurance activity, there is something called user access management review. That is a process that is followed by a lot of companies with the intent that a manager of a team would go through the permission that his or her team members have in a AWS console or could be anywhere for an application. And they manually make sure that the fact that, yes, Ashish is still required to have access to AWS. Yes, we still require say person X to still have access to AWS or not have access because their role has changed. So we need to change the permission. Now, this is the example that makes sense for local IAM user, where the only way to do this, at least the easier way to do this, is to log into an AWS console and find out what users you have and what permissions they have, and if they have the appropriate permission. However, going back to the example that I gave earlier, these days, no one is just using one AWS account. People use multiple AWS accounts. How do you do that at scale when you have multiple AWS accounts? And I think to give you an example of a scale, the last company that I was a CISO for, we had about 220 AWS accounts. That is over 200 AWS accounts and over 200 perhaps identity permutation computation you have to go through. The easiest way that works at scale is to use something called single sign-on. There is a service called AWS Identity Center that you can use for this. That uses an industry standard called SAML. SAML is a well-known open industry standard that you can find integration for. Essentially, what that means is you can use your employee username password to log in into any service as long as there is a SAML integration between your company's user store and that application. And the permission for all of this, instead of me logging into all of those 200 plus AWS accounts, I can simply go to my Active Directory or whichever user data store that I have. I can change my permission for roles over there and make myself a read-only access or an admin access just based on my one change, instead of me changing it 200 times across all the AWS accounts. I've kind of gone through it really quickly because I wanted to make sure I have enough time for labs. All right, so you should be looking at my AWS console. For people who haven't not seen this before, you can simply go there by just typing in console, if I can type in, console.aws.amazon.com is a website. Essentially, for people who have not seen this before, I'll give a quick 5-second or maybe less than 30-second intro to the console. This is the place where you select what region or what data center of AWS you're working on. I like working on the North Virginia region because that gives me access to all services. But this may vary based on the company you work for. So you would have to make sure every time you log in, make sure when you work for an organization, please only use the region that you are supposed to work in. I am using an IAM user, which is my admin user. But you can see I've got all these other things which is a scope outside of the class. But the reason I see access denied for cost, because the person who owns the account, which is my boss as well, she made sure that I don't get access to the cost, but that doesn't mean I don't have to look at it. I just want to make sure that I am able to create instances, work on all these security services that a Amazon console provides me. All of this, I would say that probably the most important thing for the first page is usually what account do you have, what region you're operating in. And this is a bit more, I think this is a bit advanced at this point in time. You can look at services, all the services they have over here by clicking on the services in the top. For us, we are working on IAM. So the easiest way, if you don't know how to find one, is just to go to search bar, type in IAM, and you can see IAM Identity Center that I was talking about so far. But for the lab, we're going to focus on IAM. So I've got 3 labs that I would like to run. One is to help you create an IAM user. The other one would be to add an IAM policy to an IAM user. The second lab would be to create a read-only role and create a group for the users that I'm creating and add a read-only role to that user group. IAM user, for quick reference, is the local user for AWS that I was referring to earlier. IAM policy is how I do access management. Read-only role is also how I do access management. User group is how I do user management. How do I combine and manage access to multiple users who have similar permission? that would be through user group. So I'm going to bring back to the console. Just clicking on the AWS logo over here brings you back to the homepage. I am still in the North Virginia region, but you can pick the region that is the closest to you or that you want to operate in. I would go IAM, and I'm looking for IAM. So my root user has MFA. I'm not logged in as MFA. I'm not logged in as root user, so that's why I don't see anything else. However, I have not added MFA to myself, so probably should add MFA at some point in time. I don't have any access keys, so this is just a security recommendation provided by AWS, which is definitely a good take. This is a bad mark for me, so I need to add an MFA next time. This also gives you a synopsis of what you have in terms of how many user groups, how many IAM users, how many roles, how many policies. Identity provider is linked to your identity center. Probably the outside the context of this class, but I'll just quickly do a summary. Identity provider is what integrates your user store with AWS to let them know that, hey, I can use single sign-on and SAML. That's what that is for. This is just this is basically just information from AWS on what new services have been announced. This is quick access to my credentials, but to manage my access key, MFA, I can go there. I can use a policy simulator to create new policies at scale if I would like to. But the purpose of this lab is to create an IAM user. So I would go into users. I already have a few users in here. I would create an IAM user by simply clicking create user. In this case in time, I'm just going to use my URL as a name. So give me 1 second. I'm going to type it in. All right. So I'm going to call it test user. Now provide user access to AWS console. The reason it's optional, and as you can see, it talks about, is there a password that I want for my identity center that's recommended, or I want to create an IAM user. I am creating an IAM user. So I'm going to go, I want to create an IAM user, which can access the AWS Management Console. If I were to untick this and simply go next, I can do that. However, the user that I create would technically just become a machine user, or at least a type of machine user, where I can perform actions using that user, but I can't log in onto what you're looking at on the screen at the moment. Because the lab is about IAM user, so I'm going to do that. Create, yes. Auto-generate password. I'm just going to do custom password. Let's think of a super secure password. Super secure password. I wasn't kidding. And that do that. Users must create a new password at next single sign-on. So if you are working for an organization, I would have this ticked because, say, for example, someone from this group, let's just say Peter was someone I was creating the IAM user. I would give them a custom password. And then I would tick that box. So when an email goes to Peter, because when I do next, there would be information requested for how do I communicate this with Peter that, hey, this is your new password, whether it's using my email channel with Peter because he's a colleague in my company. So I'll send the password through other means, or I can share across a password manager, whatever the method would be for the company you work in. You are able to use that to identify how would you send the password. So if the first time Peter tries to log in, it is going to force Peter to change the password from the custom super secure password that I thought of giving it to him. Now, this is the part where you're setting permission. I have created the user. Let's set permission for what the user can do. I already have existing groups that I have created. I have a security only, read only, cloud security engineer group. I can just simply tick one of these users. I would say permission boundary is a bit too advanced at this point in time, but the simple version is control the maximum permission for this user is a good way to describe permission boundary. Or I can just say I can copy permission from an existing user. I've got all these other users that I've worked on or I have at the moment. Some of them have cross-account access. So I'm just going to say, nope, I don't want to give any user permission. I don't want to copy a permission, but I could choose to have a policy attached directly to the user. I can search for read only. If I search for read only, there's a lot of read only. So how about I do Amazon EC2 read only? Or if I can search for IAM, I can do IAM change. Oh, IAM read only. Perfect. I'll just do that one. So I will select the permission, which is IAM read only. So I've selected the permission, which is IAM read only access, which means the user that I'm creating would only get the permission of IAM read only access. I have given it Amazon EC2 read-only access and IAM user access. That's my username. I've given it a custom password, and I've also asked it to be reset the next time it logs in. And that's the 3 permissions that I'm giving. Now, these permissions are basically permission policies, as you can see. So when I was referring to roles and policies, This is the policy that I'm referring to. Now, I would say it is a good practice to have tags in general for most resources you create. If, for example, this test user, so I could just say purpose, just gonna say purpose. I'm just gonna say AWS team. I could say this is the cloud security team. Security. So the reason this becomes important is imagine you have multiple AWS accounts. And how do you identify how many of the users that are there across all those AWS accounts, all the 200 plus AWS accounts that people would have? This is just one of them. So I've got another 199 to go through. How do I identify everyone who is part of the team cloud security? Tags would be the way you would be able to identify them really quickly as you do automation. So that's where I find the tags to be really helpful. It is a good hygiene to create and keep for yourself. Now, for the sake of this example, I'm not going to log in because it doesn't have to log out, log back in again. Essentially, what I would do at this point in time, I have an email sign-in credential, email sign-in instruction, which I can just pop open into an email, which you can't see, but essentially my mailbox is opened up. So I will close that. But essentially, I am sending, in my case, I was using Peter as an example. Sorry, Peter. But I'm going to continue using you for this. So I'll send Peter this console URL. I'll send him the username. I will also send him the password. And I'll basically, because it will force him to reset the password after this, I would just share that or download this over PSV or share that using a password manager. This is probably the end of the first lab where I have assigned a permission to it. I have added a IAM policy. Actually, let me just come back to the screen. You haven't viewed. Yeah, so this is because it thinks, hey, you need to save your password somewhere before you just go away from the screen because you would not get that screen back again. Because I'm not logging in, I don't really care. But if I was genuinely logging in or generally making sure that someone is required to have access, I'll make sure I have a copy of that password. Right. So I have created that user. And if I can go back, this is pretty much, if I just refresh this. Yep. So I have this test user that was created. Not part of any group, no activity, never logged into the console and the ARN and created time 1 minute ago. So that is the user I was created. And that is the end of the first lab. This is very much a use case for what you would do as a cloud security person who's managing an AWS account for someone in an organization. What is the difference between IAM policy and IAM role? Yeah, so the difference between a role and a policy is that roles are basically, these are specific permissions that you can group together for either AWS services or AWS users. AWS policies, however, can only be assigned to individuals. So you will see this custom managed are the ones that I created. These are permissions that I created. Similarly, for roles, you can have custom ones. I don't think I've created any, but I'm just going to say, I usually use the word custom. So I know, so these are ones that I created. So VPC flow custom, EC2 patch custom, and all of them. 19 minutes ago, I created another one. So all these are ways for me to, so role is a way for me to provide permissions to AWS services as well as a group of AWS users. Policies, on the other hand, are a lot more granular. A role can have multiple types of permission around it. So I'll probably rephrase this, is an identity you can create for specific permissions with credentials for a short duration. Policies is an object that defines an base. These are specific permissions. So if I look at administrative access, I can't change what's in here. Like I can create my own custom one, but these are policies that are created outside. These are policies that are created by AWS. And the advantage for these are I can just basically go to my test user and say, actually, I want to add a permission and I want to add a policy. Not policy, sorry. A permission is what I was saying. I said permission, but I went to policy. I want to add a permission. And I'm going to go back to this, attach a policy. I can attach and access analyze the policy if I want. That's where the advantage of this is. So if you notice, I could not add a role here. There is no option for me to add a role. I have to add a role to a group. So I hope that makes sense. Like policies are more for individual users or AWS IAM users. Roles tend to be, and we can go into the granularity of temporary users. There are other kind of users as well. I would say there's a lot more complexity you can add to the role definition, but to keep it super simple so everyone understands it, roles would be primarily for AWS services or data accounts. Since you said security engineers deal with several AWS accounts and passwords too, as admin security engineers, where do we save the user account details and password? Do you have any recommendation? The question is more around how do you share account details and passwords, especially if you're looking at hundreds of users. Most often, what you would find is you would use something called AWS CLI, and the best example, if you see this button, if you click on that, you'll see it opens an AWS console. And once it loads up, this is one easy way of doing it. Earlier, you had to set it up locally, do a lot of things with it. So I can just do over here, AWS, and it should give me a keyword for it's an AWS help. What do you want to do? So I can do, okay, AWS IAM, am I typing? IAM help. And that will give me options for what I can create as IAM using automation. So I can do add user to a group. I can attach role. I can change password. I think the one you would find most fascinating for the purpose of what you're referring to is if I can get create user. There you go. So I would say for example, Charles, I had 20 users that I had to create. I know that I have create user. So I'll go, okay. So the command that I need to type is AWS IAM create dash user. And then I'll basically make a list. So obviously, every command that you put in would have a format. I would put the 20 names in here or in a CSV file and use that to create the user with a default credential. And the switch enables for, so when I say default credential, the default custom password that I gave, I'll give everyone a similar password or different password, however you approach it, and use that as a way to create IAM users at scale across multiple AWS accounts and share that password. Well, you still have to email individuals. That part has not been automated, but AWS CLI is a way to be able to do the automation. I can go deeper into it, but that's probably would be too advanced for a lot of people. Let's go to the next lab then. Create a read-only role. So as I was referring to earlier to Raymond's question, I can create a custom role, or I can just search for any existing read-only role. Doesn't seem to be a read-only role. So this is an opportunity for me to create a custom role. So I'll go, okay, I'm going to create a role. What kind of role would it be? Is it for an AWS service? Is it for allowing entities in other AWS accounts? This is the third-party account that I was referring to. Or this is a web identity or SAML. Or would you want to create a trust policy? I'm going to keep it super simple for this class. So I'm going to say AWS service. And I'm going to say that I want read-only access to, let's just say EC2. It's a commonly used. I'll just go with the regular use case. Yeah, my use case is EC2. And I would say, now, see, this is where I was referring to. Your roles can be, so policies can be attached to roles as well as individuals, but like roles is a collection of different permissions. It's like a superset, if that makes sense. So now I can search for the same IAM read that I had before, IAM, and I would see the same IAM read-only access. I'll go next, and I would say this is my custom IAM read only, so that I can read only role. Okay, awesome. EC2, not IAM. EC2, because the reason I knew I was not IAM and EC2 because I saw the service name. Probably this is a trust policy, and this is going to fail for sure because I've added IAM road. So this is a clear rookie mistake. I use a policy which is IAM role, but I'm saying that anyone who has an EC2 instance should be able to use this permission as well. And this is where it becomes complicated. And Shard, you're right. I should have used EC2. So I'm going to go edit this and untick the IAM box. So, IAM, untick that, and I go for EC2. EC2 full access is Amazon EC2 read-only access. All right, now that makes sense. I've got EC2, and I've made sure that, so creating this role also means that I can attach this custom role to an EC2 instance. Now, EC2 instance, for people who don't know, it's a service from Amazon for virtual machine, for virtual servers. I'm not going to add a tag here just because I want to make sure I finish all the labs in the time that I have. Oh yeah, of course, it can't take spaces. So I'm just going to take that. The reason I use the word custom, but you may use something else, it's just for me to easily search for any custom roles that I've created. That is the IAM role. And if I do custom, I can see my custom EC2 read-only over here. Now, the next lab after this is I need to create a user group. So in a scenario, to Sharat's point earlier, I have a lot of users across the board. How do I make sure that I have the right people across the board? So I have created a user group. So I'm going to create a user group called read only, which I have created before, but I'm just going to replay this once more for everyone. I can add users to the group straight away. So I can just say my test user should be part of it. I can also attach additional permissions, all 913 of them. But I'm just going to search for my read only. Actually, if you want a read only for across AWS account, there is a security audit account, that one over here. That usually is an account that usually is supposed to read only for pretty much majority of services you have in AWS. So I can use that as a example for this and go security read only. Let's just actually call that. That probably is a better name. Security read only group. And I do create group. So now I have a new group, and once it loads, it has one user in it, and the permission has also been defined. So if I go into this, I can see that, yes, this is the test user. Now, the last part of the lab is to add permission, which I already did on the previous end, but you can do the same thing as we did before. Attach policy, and I can search for read only and then search from there. But I'm just going to repeat myself again, so I'm not going to show this. But that is the end of the third lab as well, where just to summarize quickly what we have done so far, I've made sure that I have created IAM user. I've also made sure that I have provided appropriate access to those IAM users. I've also made sure that I am providing read-only permissions only to them. I have created username password as well for them. I have created a user group so I can manage them at scale. And I've also given them read-only permission. Shah's question, may I need to check the list of policies and how it works? Thanks a lot, learn basics, which I've never explored. Worthwhile noting another pattern, if you are operating in a company cloud security, a company AWS account, all the IAM users you have, make sure there are no inline policies. You know how we attached a read-only policy to those users? Make sure those are only the policies that they are supposed to have. Because most organizations would say either have we don't allow for any IAM user policy, and we only want identity center single sign-on as a policy. Some organizations would say, hey, I'm okay to have IAM users for third party. So based on the nuance of how the organization is using IAM user, I would definitely just check if the right policies are attached. That's kind of brings you to role-based access control. But hopefully that helps. That is primarily what I wanted to cover. Probably is not relevant for this, but in the next class, which is a bit more advanced, as part of the Cloud Security Bootcamp, what we cover is managing permissions across multiple AWS accounts, cross-account role, third-party IAM. The lab over there is more about cross-account. So the example that I was referring to over there is if you have over 200 AWS accounts, why have 200 IAM users? Why not just have one user and use that one user to just go over to all the remaining 199 accounts? And this is IAM project for the homework. That's pretty much what I wanted to cover. This is obviously part of a bigger bootcamp, and I appreciate you guys have signed up for the free one as well. So on Cloud Security Bootcamp, this is the website. That's the boss lady. She's the one who's I'm just a trainer, as I like to say it. The free training videos basically goes to our YouTube channel on the Cloud Security Bootcamp. At the moment, the one that we have open is AWS Security Fundamentals. We have Cloud Security Podcast as a YouTube channel where we do interviews with other cloud security practitioners. If you are just looking to learn from other cloud security practitioners on what they do over a interview format, that is Cloud Security Podcast, available on YouTube and all the audio streams that people refer to. But for Bootcamp specifically, if you head to the Cloud Security Bootcamp YouTube channel, you should see videos like these and the others that we create for free over there as well. I wish you all the best. And if I see you next class, I'll see you next class. Otherwise, I'll see you in the Bootcamp. Thanks, everyone. Enjoy the rest of your day. Talk to you soon. Bye.